So good evening to everyone. Hope my audio is clear to everyone. Anyone can please reply. My audio is clear. Can text in chat box. I think have no issue in the my voice, right? I think my audio is clear to everyone, right? Okay. So okay, we will wait 2 more minutes to join some more participants. We will start from 4-5 p.m. onwards. Okay. As of now, we joined only less people only, so we will wait 2 more minutes to join some more participants. So then we will start today webinar. Okay. Okay. We will start the today webinar. So maybe if any other participants maybe will join in between this session. Okay. So just a minute. I hope my audio is clear, right? So if any issue in the audio, so please let me know. You can text in the chat box. Otherwise, you can unmute your mic. You can let me know. So we will start the today webinar. Okay. So myself Mariappan D, consultant in 3D printing additive manufacturing. I am working in the NILIT, National Institute of Electronics and Information Technology, Chennai. Okay. So actually, under the Future Skill Prime project, we are conducting various webinar in related to 3D printing additive manufacturing field in monthly. So in every month, we are conducting different webinars in related to 3D printing field. So like same this month in November, we are conducting metal additive manufacturing and its application. So in this webinar, we will discuss about on the introduction about on 3D printing and metal additive manufacturing, how many classification under the metal additive manufacturing process, and how what are the application in the metal additive manufacturing, and what are all the advantages. So where and why we need to go metal additive manufacturing. So these all the things we will discuss about on the today webinar. Okay. So if you have any queries or if you have any doubt, so you can also text in the chat box. So I will end of the section. I will answer your queries. Okay. Okay. We will move on to the webinar. So if anybody not getting my audios, please let me know. I will check. So I think there is no issue in the my audio. So I will start the today webinar. Okay. So before moving on to the topic, first I will explain the uh, about our NILIT Chennai. Okay. So then we will discuss about on the today topic. Okay. So NILIT is a National Institute of Electronics and Information Technology. It is a autonomous scientific society under the administrative control of Ministry of Electronics and Information Technology. It is a government of India. Was set up to carry out human resource development and related activities in the area of information, electronics, and communication technology. Okay, so in NILIT Chennai, have totally we are conducting various different courses. Okay, like in certificate course and short term courses and like foundation courses, like that we are conducting various courses to different industrial people and different students, different level of candidates. We are conducting different courses. Okay, so 1 minute, I will check my, just a minute. Okay, sorry. uh, So actually, NILIT Chennai, it is started in 2010 onwards. So NILIT I totally have almost 40 plus institute in all over India. Okay, in south side NILIT Chennai and NILIT Calicut have. Okay, so in NILIT Chennai we are conducting like various different courses to various people. Okay, so we are conducting various certificate courses, various foundation courses, various short-term courses, like that we are conducting different courses. And related to our mechanical field and related to our 3D printing, so we are conducting two different courses. One is in a CATIA V5 course, another one is in a 3D printer course. It's a development of FDM 3D printer course. Both are in certificate course. Okay, so if you want to register that course, you can check the below link is given, right? So you can check the link, you can register the course. Okay, so as of now we have started only one course, like online certificate course in development of FDM 3D printer. So that course only now the registration is opened. You can also check and register that course. Okay, the CATIA course, it may be start on the maybe next week onwards, maybe we will open the registration, then you can open, then you can check and register the CATIA V5 course. Okay, but as of now only we opened that the 3D printer course. You can check the link. Okay, you can register it. So this is the our development of FDM based 3D printer certificate course, flyers and some more information. So actually this course last date of registration is 23rd November. Okay, so this course will start from 25th November onwards. Okay, the course fees is just 2000 rupees, including tax, just 2000 rupees. And you can check the registration link. And if you have any queries, you can contact, these are my number. Okay, so uh, you can check and register the course. Only here, very limited seat only we are open per batch. Okay, already some 50 60% of the seats are filled. So you can register the course as soon as possible. And here these main advantages of the course: we are giving live instruction daily 4 hours from afternoon 1:30 to 5:30. Okay, and it is a 80 hours course. And also each day recorded video will be saved in your LMS portal. Okay, this is a purely online mode. But suppose if you have interest, or if you are doing any project related to 3D printing, maybe you can directly come our Naili Chennai office. You can learn our 3D printing facility, and also you can visit our lab. Okay, if you have any doubt, you can also interact in offline mode also. There is no issue on that. So so this is some more information in the related to our development of FDM based 3D printer course. So next one is our it is a very important one. So under the Future Skill Prime project, so we are conducting different training program on different courses. So one of the thing is, it is a bridge course. So the bridge course, it is a very useful for learning, or if you want to learn some introduction to 3D printing and CAD modeling. So this is a very suitable course for you. So the course fees is just 4,000 rupees. So now in the flyer actually they mentioned 6,780, but now this the price is updated. So maybe I will update the poster in the later. So this price, it is 4,000 rupees only, including tax. So you can check the given registration link is given, right? You can check the link, so you can register the course. So this is a course will certified by SSC NASSCOM, and the course duration is 90 hours. Okay, so you can check the course curriculum and highlights and everything in the portal. You can check here the course link will given. So through this link you can check these about this bridge course. You can check our things. Okay, if any doubt you can contact number is there. So during that registration, or if you have any doubt in the uh, if you doubt in the things, you can. Okay, my sound was not right. Now it's okay, or it's not clear. I think hope my audio now is, I think, clear, right? You can check. Okay, so this is the our structure, NILIT structure. Ministry of Electronics and Information Technology. Under that you are working MOS Electronics and IoT, and under the secretary there are different division is there. So in the autonomous society there is a different institute organization is there, like CDAC, CMET, NILIT, SAMIR, STPA, HERNET, like that. So NILIT is one of the autonomous society working under the Ministry of Electronics and Information Technology. Okay. So in our NILIT Chennai, these are the some important thrust area. One of the important thing is our 3D printing additive manufacturing. Apart from this, we have some more areas like information security and cloud computing and data science and embedded system. Okay, so these are the some important thrust area in the our NILIT Chennai. Okay. So activity in our NILIT Chennai, we are conducting the already mentioned no the different training program, like in the first Prime project. Under that, we are conducting different government official training program like webinars, and also we are conducting some seminar also for students. Okay, like that we are conducting different training program in online and offline mode. Okay, and we are conducting capacity building project funded by Minister of Information Security, ESTM and EPDD, FutureSkills Prime. So like that we are have handling different project. Okay, in different area, and total number of candidate trained 30,000. It means actually we are already I mentioned, right, we are conducting different courses and different training program. So in that we are certified more than 30,000 candidate in different areas. Okay, so and also we are monthly basis we are conducting DLC examination. So in that we are certified more than 25,000 uh, candidate in that. Okay, so these are these our activity, some important activity mentioned in the slide. Okay, so if you want to more information about our Nailit Chennai, you can check our Nailit Chennai website portal. Okay, so regarding the course and regarding the course prospectus, uh, so course details, everything will be updated in our Nailit Chennai portal. So you can check our Chennai portal, Nailit Chennai portal website. You can get more information about that. Okay, so if you have any doubt in this, so you can also text me. Okay. Okay. So up to now we are discussed some kind of uh, basic information about Nailit Chennai. I think hope some of the candidates already know about our Nailit Chennai. Okay. So now we will start uh, our main topic in today webinar. So metal additive manufacturing and its application. So before we move on to the metal additive manufacturing, we will discuss about on the what is mean by additive manufacturing. Okay, so it is mean by the additive manufacturing a process of joining materials to make object from 3D CAD data, usually layer upon layer, as opposed to subtractive manufacturing methodology. Okay, so in this 3D printing process, the process will happen in layer by layer to create object from the CAD data file. So this is the name called as a 3D printing. So actually there are different name is there. So some of the people will call it as a 3D printing. Some of the people maybe know will call it as additive manufacturing process. Some of the people will call it rapid prototyping. So what is mean by that means, so all the name is the same. There is no difference in that. Okay, but initially this additive manufacturing process is developed for making prototype purpose, right? So that is the name. That is the reason the name called as a rapid prototype. Okay. So after that, this process, this technology will evaluated into different industry, different application. Like nowadays, the 3D printing is it is used for like the 3D printed parts can directly use the end use application. Even metal and even some of the plastic parts you can directly use for the direct end use application. Okay, so like that the technology will be evaluated into next level. The various companies and the various people nowadays are using 3D printing technology for different applications. Okay, so, yes. So if you have any doubt, you can ask in the chat box. So at end of the session, we will discuss. Okay. So 3D printing means it is a process is very simple. From the CAD data, it will create 3D object in layer by layer process. Okay. So here there is no metal removal process. So here there is no required for any tool holding and wood holding devices. So here the wastage of the material is very less. So these are the some advantages, these are the some important points comparatively in the conventional manufacturing process. So this is a simple concept about 3D printing. So next one is additive manufacturing evaluation. It means how 3D printing it is evaluated. So hope all of you know 3D printing it is started, first technology started from 1980s. First developed technology is SL, stereolithography. So already I informed no, there is in 3D printing there are different kind of different types of 3D printing technology is there. So one of the technology is very important technology and widely used technology name called as SLA. Okay, this SLA technology is a first developed 3D printing technology. The name person is a Chakkal. He is from 3D system. 1986 SLA technology is developed and patented. Okay, so you can see this fourth one 1986, and after that only SLS and SLA SLS and FDM and CJP and there are many technology after that that developed. Okay, but first developed technology is the SLA technology 1986 from 3D system. Okay, right? So you can check some more information. Actually, the first mechanization is started 1770 and the first computer is developed in 1946. Like that, there are different evaluation is there. You can go through it. Okay, but our important point is the first developed technology in SLA in 1986 is from Chakkal, is from 3D system. Okay, so after that, you can see FDM technology. It is developed in 1992. Okay, so this 2 point is very important now. So next one is what are the difference between the additive manufacturing and the conventional manufacturing process. So why we need to go additive manufacturing process comparatively in the conventional manufacturing? That is a very important thing. So there are nowadays there are different manufacturing processes there. Suppose I want to make one mechanical part. Example, you can take one gear. So gear I can able to make different process. It means different manufacturing process nowadays is there. So I can able to make different gear in a different manufacturing process. Like if you are going with conventional manufacturing, there is you can able to make in gear in lathe, milling machine, shaping machine. Okay, there are like that. There are different machineries there. And if you are going with the metal forming process, I can able to make gear. Okay, why? And casting also I can able to make gear. So why we need to come with 3D printing process? What is the advantage? What is the uniqueness in this uh, additive manufacturing process comparatively in the conventional machine? So it means you can see here. I mentioned some few points, important points. So additive manufacturing process have some close relationship between the conventional machining process. Yes, conventional machining is also computer-based process which is used to manufacture a product. Conventional machining process is which material subtraction is occurring to produce a desired product. So you know, right? All of you here know the conventional manufacturing process is a metal removal process. It is a subtraction process. So initially we need to load the one solid block. From the solid block we need to remove the material. You can get desired object. So that is the name called as a conventional manufacturing process. Conventional machining process. Okay. So in additive manufacturing process, it's not like that. Here there is no need to cut the material, so wastage kind of things is very less. So here already I mentioned no, the material will be deposited in layer by layer process. You can get 3D object, you can get physical object. So that's why the wastage of the material is very less comparatively in the conventional manufacturing process. And here there is not required any work holding and tool holding devices. So you can see these images A and B. A is a process, it is a conventional manufacturing process, and B is a additive manufacturing. Okay, so already I mentioned no that gear. For example, you can take one gear. So in the gear, suppose I want to make that gear part. It means in the conventional manufacturing process, we need to involve different operation process. Like we need to go drilling, we need to go with milling machine, then we need to go grinding, and suppose if you required, we need to do polishing. So these all are the lengthy process. It means there are different operations it will be involved. So it means it also the process lead time. The part manufacturing lead time will take more, right? Comparatively in the additive manufacturing process. But in additive manufacturing process, it is not like so in conventional manufacturing process, not like this additive manufacturing. So here in additive manufacturing process, easily you can make your object, okay, without any work holding device or tool holding device, or without any uh, high skilled manpower, without a higher programmed part. It is not required. Easily you can make your object, okay, by using 3D printing technology. And here main thing is the wastage of the material is very low, because the wastage here will be considered, it means only the support material, okay, that support material only is a wastage, otherwise there is no wastage in here, okay. And the main thing is uh, in the conventional manufacturing process, we need different tool holding and work holding device for making different objects. Suppose I am manufacturing or I am machining on impeller. Next, I want to load gear part means, so we need different work holding device. It means that there is a that work holding device we need different. Each part we need different work holding device and tool holding device. But in 3D printing, there is not required any work holding or important point. And another thing is, in 3D printing, there is not required high skilled labor. It means even of course if you are going with the metal, maybe required for some medium level skilled operator level. But if you are working with polymer, there is not required for high skilled labor person. Okay. And the programming also is very easy comparatively in the CNC programming. Here it is programming is automatically it will done by software. So that's why here there is no need high skilled labor person, and program also is very simple. And another thing is wastage is very less in 3D printing. And if your reduced wastage mean automatically your product cost also will be reduced. Okay, that is an important thing. And the product cost as well as product lead time also will be reduced. Product lead time will be reduced, mean automatically your production will be increased. So these are the advantages. These are the main important points comparatively in the conventional manufacturing process. Okay. So these are the some kind of classification of additive manufacturing technology under the ASTM. So actually ASTM is a one standard, America's standard testing material. So under these 3D printing technology are classified into 7 types. Okay, one is in a material extrusion, another one is a vat polymerization, sheet lamination, powder bed fusion, and binder jetting, and material jetting, and DET, direct energy deposition. So these are the 7 different 3D printing technology under the AST, right? So in the I think last webinar, last before webinar, I think we have discussed some polymer related 3D printing technology like material extrusion and vat polymerization and sheet lamination and binder jetting, and even though SLS also we are already in previous webinar we have discussed. So maybe if anybody missed, maybe you can let me know. I will share the recorded video link. Maybe you can see, you can watch the video. Okay. But now mainly we will discuss about on the metal additive manufacturing technology like DET and your DMLRs and EBM and okay, and also your SLM. These three four technology metal additive manufacturing technology only today webinar mainly we will discuss. Okay, next 10 to 20 minutes. Okay, so these are the some classification under the ASTM. Okay, so you can see each technology already. I think these things I already we are discussed, so I will not more discuss about on this webinar. So just I will explain just to some basic definition only. So in wad polymerization it is a uh, it is a liquid based technology. This technology by using the laser source or by using the light source, UV light source, cure the liquid material, you can get the 3D object. Okay, this technology is widely used for automobile and aerospace application, and this technology you can get more accurate. Okay, and the material jetting, it means MJP technology, polyjet technology. So in this technology, it is a very finest, very accuracy, precious part. Usually, you can 3D print with this technology. Okay, this technology also the part material is of support material will be different. Part material will be like PP material or nylon material or maybe in the like wax material. Support material is like in wax. Okay, example you can take 3D system machine MJP 2500 or 3500 machine. So in this machine the materials of part material it is like a nylon material or PP or some kind of rigid material. Okay, then support material is a it is a wax. It's an industrial grade wax material. So once your part completed, easily you can post for the part. Sorry. And the material extrusion, it is already we are know most widely used technology, FDM technology. So in this technology, the material is like wire format. That wire will be melt in some temperature, so that melted material will be deposited in layer by layer process. Then you can get your object. So like this only that process will be happening. Okay, this is a widely used and most of the R&D can easily you can do with this technology because this is a very easiest process. Easily you can test your material in this technology. The another one is a binder jetting. It is a powder based technology. Here the material is like powder format. It may be the nylon or PP material will be converted into powder format. Then by using the source or laser source, cinder the material, then you can get the 3D object. Okay. Then another one is a powder bed fusion technology. It is also similar to binder jetting. And sheet lamination is a different technology. It is a like unique technology also. In this technology, used for sheet kind of material is like a sheet format. That material it may be metal or it may be plastic or it may be or some kind of sheet. Okay, that material in layer by layer will be trend and you can get object. But in this technology, problem is you cannot get more rigid part. It means okay. So this technology it is a not widely used technology because have some problem, some kind of limitation also is there. This sheet lamination process and the DET direct energy deposition. This is the one of the metal 3D printing technology. Okay, so in this technology, the metal wire it melt in layer by layer process and deposit in layer by layer process, and you can get 3D object. Okay, this is the some classification. So already we are some of the candidate already know very well about on this technology. So I will not more discuss. I will not more give information about on this technology because previous webinar already we are discussed. Okay, so now I directly go with metal process. Okay, so in the metal additive manufacturing process, normally they classify into two sections. One is a powder bed fusion, another one is in a DET process. Okay, actually in the metal 3D printing technology, okay, actually there are classified into two different types. One is a powder bed fusion, DET process. DET process. So actually powder bed fusion is, right, this technology, that material, input material, it like in met, these are powder format. And the DET, direct energy deposition process, the input material is like wire format. It means that material, it will be converted into like wire format. That the wire will be melt and deposit in layer by layer process. Okay, then you can get object. It is a DET process. It is almost similar to the FDM. Okay, but we will discuss. We will discuss some more detail in the DET and powder bed fusion. Okay, so but why we classify these two different technology means, actually, in DAT process it is a low cost 3D printing, metal 3D printing process. Easily you can test any material. Okay, and also here this DAT process, easily you can make your object. But problem is here you cannot get more accuracy of the part, and you cannot get better surface finish, because it is a process, it is already mentioned, it is a similar to the FDM. You know, right, FDM process. In FDM, how that surface finish it will be there. It means the surface finish will be a very rough. After post processing, only you can get some kind of good quality of the part. Like same thing, DET process will be happen, but cast and machine process, technology wise is very simple, and cost wise, product cost and machine cost will be very less comparatively in the powder bed fusion. But coming to the powder bed fusion technology, it is a famous technology, famous process is a DMLS, direct metal laser sintering. Okay, DMLS. So in this process, by using the laser source, okay, that material will be sintered. It means wherever the laser will pass on, that area will be, material will be solidified. So that area you can get object. So like same process, it will be happen in every layer. You can get your object. So instead of you are using laser source, you can use the electron beam also. Okay, but cost wise and some accuracy level, it will be different by using the electron beam source. Okay, but most widely used technology, most used source is a laser energy sources. Okay, so we will discuss more about on this in upcoming slide. So first one is we will discuss about on powder bed fusion. So normally we are all of you know, there are in plastic, we are using the different uh, materials like nylon, PP material, and PLA, ABS, and glass filled nylon, and fiber based materials. Okay, and Pro HD and PETG. Like that, we are using different polymer based material in plastic 3D printing, right? So we are using different technology in plastic polymer based technology. We are using MGP, SLA, FDM, okay, CJP. So like that, there are different polymer 3D printing technologies there, and also we are using different materials, polymer materials. But in metal, you can see only we are here also some kind of limited materials only you can able to directly you can 3D print. Suppose I developed a new material means, so that material it may work or may not work in 3D printing process. So that is the problem in the some limitation in the 3D printing. Okay. So here only in metal 3D printing or plastic 3D printing, so only limited materials based on the technology. So you can select the material only that what are the technology. Suppose in DMLS only you can able to print cobalt chromium and stainless steel and tool steel. These are the some kind of standardized material only you can able to print. Like same thing, each technology has some limitations will be there in the 3D printing. Okay, that only have limitation. But apart from this, in metal 3D printing, you can easily print any part and the very accuracy part easily you can make and faster comparatively in the conventional manufacturing process. Here you can make very faster comparatively in the conventional manufacturing process. That is the reason metal additive manufacturing process nowadays many automobile industry and aerospace industry and R&D companies, there are many companies they are using the metal additive manufacturing process. Okay, so widely used material in metal additive manufacturing machine is a SS material, 174 pH stainless steel material, tool steel and cobalt chromium and hardened steel. Uh, these are the some materials are widely used in the metal additive manufacturing process in the DMLS process. Okay. So this is the some of the materials list out in the metal additive manufacturing process. So next one is you can see the binding mechanism. So this is the very important thing. Actually, I previously mentioned no in the metal additive manufacturing process, the particularly in the DMLS direct metal laser sintering process, the used input material is a powder format. Actually metal material will be converted into powder format. Okay, in that powder we need to pass the laser source. Okay, wherever we are passing the laser, no, that area will be solidified due to the some kind of chemical process, chemical reaction between the laser source and material. So this mechanism, that kind of binding, there are different process will be there. You can see here primary binding mechanism in powder bed process. These will be classified into four process. One is in a solid state sintering, another one is a chemically induced binding, another one is a liquid based sintering, another one is a full melting. Okay, so
without
these are the
in the
just a minute.
in that like I am going to take sessions basic mechanical and
So just a minute. Yes, these are the some binding mechanism commonly are used in the metal 3D printing. So okay, so but in this you can see liquid based sintering, partial melting. So here not happening in the metal 3D printing process. That melting will not happen in the full stage. It does not mean full melting will not happen. It is a partial melting. That name called as a liquid phase sintering. So in this liquid phase sintering is classified into two types. One is in a distinct binder and structural material. Another one is a indistinct binder and structural material. See these are the two different partial melting process in the powder bed fusion process. Okay. So here you can see there are different particles will be there. Of course, separate particles and composite particle and coated particle under the distinct binder and structural material. Okay, so these are some basic information about on binding mechanism. So I will not more discuss about on this. So you can go through these things. Okay. So next one is, what are all the important key factors involved in metal additive manufacturing technology? So metal additive manufacturing process, it is not like already I mentioned, no, it is not like similar to the polymer. Okay, the process wise it will be different. Example, you can take SLA technology. SLA technology, how it will work. So initially the material will be liquid format. Okay, then we need to load, we need to pass the laser from the top. Okay, wherever the laser will pass, that material, that area part will be solidified. It means simple process. The material will be liquid form. Wherever we are passing the laser, the liquid material, that area will be solidified due to the some chemical reaction, right? After that part completed, you can directly take, you can clean the part, you can directly use it. There is not required for more post processing work in the normal polymer 3D printing technology. But in metal additive manufacturing process, it is not like that. So actually the maintenance of the machine is also very difficult. The metal additive manufacturing process, the first of all, there are different constraint is there. We need to maintain proper chamber temperature. Okay, and we need to during the printing 3D printing process, we need to maintain proper gas. We need to use some proper inert gas like nitrogen or argon gas. We need to properly supply, and proper air supply with constant air pressure, it is required. Okay, and a proper room temperature, it is very important thing. If you are not maintaining proper room temperature, it will affect your print quality, as well as it will affect your printing time. Okay, and main thing is we need to maintain proper chamber temperature. Okay, these are the very important thing in the metal 3D printing. Okay, before you are starting the metal machine. Okay, and in the software side also, it is not like polymer. Suppose if you are done any mistake in the support in the metal, means your whole part will be failure. But one part, one build will failure means surely you can lose your money, because in the it is not like it is not like a plastic 3D printing. If you are wasted one build, your surely will of course you can lose your major cost in the metal 3D printing. So that's why here you need to more concentrate on machine side as well as in the slicing side also. The support structure and the support type, and where we need to give support, these things, it is you think you can concentrate on more. So these are the things will be vary on one part to another part. Suppose I am slicing on simple block, so you can give like a solid support. Suppose I am slicing on impeller part, means that time you can give like a line contact support. So it means each part have different support structure it is required. So there are different constraints, there are different process things will be there in the software section. That one maybe we will discuss in the maybe next webinar or upcoming webinar. We will discuss about on the metal slicer software. Okay, that time we will discuss more about on the metal 3D printing software. So that time we will discuss later. So these are the some kind of key important factors. One is the energy source. Normally, the metal 3D printing process, we will use the laser source, the electron beam source. These are the two important and mainly used sources, energy sources in the metal 3D printing. And the material already mentioned. in wire format or either will be used in powder format. Another one is shaping material. So binding or melting or cinder. These are the shaping material. And another one is the atmosphere. So already I mentioned no, we need to maintain proper inlet gas and vacuum we need to properly we need to maintain and properly we need to maintain the air connection. It means proper air we need to supply. Another one is a build volume, limits the part size. So normally, actually in metal 3D printing, problem is the cost of the machine it will be higher. So if you are going with 3D system 100 mm, 100 mm build machine, the cost of the machine it may be is around 80 lakhs to 1 crore approximately. If you are going with high standardized machine, even if you are going with 100 mm, 100 mm machine, the cost of the machine it may be 80 lakhs to 1 crore approximately. Okay, but of course if you are going with some China or some other local party, maybe cost will be 50, 70 lakhs. Okay. Here the problem is the limited part size. So you cannot able to print 1 meter into 1 meter in single part. Maybe you can slice the part into 2 to 3 different cut. Then you can build it. Like that only you can able to print. So another one is a part density. So it determines the mechanical properties. It is purely based on your uh, your your material. So what are the material you use? Based on that material only it will serve. So first one is the electron beam melting. So this electron beam melting, it is this technology. The material format will be and used in titanium or cobalt, chrome, nickel or superalloy. So here the material, the format is a powder format. So using some kind of electron beam source, okay, you can melt the material, then deposit layer by layer. Okay, you can see the image. So this is the material will be in powder format. It's stored in the flat build. Okay, from the top we can pass the electron field energy. So wherever the electron beam will pass, that area will be solidified. Okay, here the material is not centric. Here our material will be melted. That is a name called as the electron beam melting. Okay, the material will be melted, then the material will be solidified. So here the technology, layer thickness minimum it can able to print 50 micron, maximum 200 micron, and the laser that electron beam part size is a 150 micron to 2.5 micron. The maximum build volume size is 250 mm into 430 mm. So this is the electron beam melting technology. And another one is selective laser melting process. So in these technologies, a widely used technology. And here the material we use aluminum, titanium, tool steel, cobalt, chromium, nickel. These are the widely used material in the selective laser melting process. And here also, comparatively in the electron beam melting process, here the layer thickness will be very less. So here the layer thickness, even you can able to print even 20 micron also. Okay, but maximum build size here will available in 500 mm into 500 mm, and here will be used the energy source will be laser. So what is the main difference between the electron beam melting and selective laser melting means? Only the main difference is here will be used laser energy source. In electron beam melting, we are using electron beam source. That is the main difference in related to energy. Otherwise, the process will remain same here also. Here also the material also like same powder format. So whatever material, aluminum or titanium or nickel, so the material will be converted into powder format. Okay, that material will be loaded into the build platform. Okay, then start the process, the laser will pass into the material. Wherever the laser will pass, that area melting will happen. Then the part will be made in layer by layer. Like process is similar to both in electron beam melting and this selective laser melting. It will be same. Okay. Yes, EBM electron beam melting is actually this selective laser melting. It is a process is very better than EBM process, because this selective laser melting process you can able to make even 20 micron also. Here the laser spot size it is very less. You can easily print very accuracy part, more precise part than the electron beam melting process. So that's why the most of the companies, the most of the automobile and aerospace companies are using the direct metal laser sintering process and a selective laser melting process comparatively in the. But of course, this process cost will be more comparatively in the EVM process. But here, these technologies SLM only will give more accurate part and more precise part comparatively in the EVM process. Okay, because here you can see 20 micron start from 20, but EVM it will start only 50 micron onwards. Okay, so that is the reason this technology are widely used technology comparatively in the EVM. But anyway, cost wise, it is a little bit higher than these two processes. Next to one process is a DET, direct energy deposition. So this process. Okay, sorry, actually I received a call, so that's why my network connectivities are disconnected. Okay, so sorry for the inconvenience. So actually, in DET, direct energy deposition process, this is also very low cost metal 3D printing process comparatively in the powder based technology. Okay, in DET there are famous manufacturer. These are like MeitY, this MeitY and like same thing. There are many manufacturer is there. So in this technology, uh, the material format will be used in the wire format. That wire will be by using the some laser that that wire will be milled and deposit in layer by layer process, you can get object. So in this, that wire will be used in the SS material or aluminum material, or it may be in the mild steel material. There are different material will be used. And here also we need to maintain some kind of chamber temperature and inner gas and proper cooling system it is required. Like that, there are different maintenance also here will be required. So if you are coming with metal 3D printing means surely there is many maintenance will be required comparatively the polymer based 3D printing technology. So but this technology very cheaper and easily you can make your object. It is also like same similar to the previously we discussed, right, TET, same, but only thing is we are instead of we are using laser, we are using the electron beam. That is the process. Okay, so I think this today webinar I given just basic introduction about on metal additive manufacturing only. Maybe in the upcoming actually in our NILIT Chennai, we are organizing monthly webinar. Monthly in 3D, only the 3D printing sector, we are conducting monthly webinar in different topics. Okay. So in next month, maybe we will discuss more about on the metal additive manufacturing slicer. Okay. So like that, monthly wise, we are conducting different topics related to the metal and the plastic 3D printing webinar under the FutureSkills Prime project. Okay. So hope I think this webinar will be more useful to everyone. So you can check any if you have any doubt in this, anybody please ask in the chat box. And also I will inform another one. I think some of the students are joined. I think late. So we are conducting different courses. The bridge course under the Future Skill Prime project. We are conducting bridge course. So this is a very important one. So another one is we are conducting online certificate course in development of FDM based 3D printer. So you can go through this link. You can register the course. So this course is very cheap. It is 80-hour course. We are starting this course from 25th November. So last date is 23rd. You cannot wait up to last date because here only the limited seat, 50 seat only we are allowed. Okay. So you can go through this registration.nailitchennai.edu.in and you can also check our bridge course, okay, through this link. And also if you want more information about our courses, you can check our NILIT Chennai website. Okay. So surely we will discuss some more points in the upcoming webinar related to metal as well as in polymer and slicing software related things. Okay. So we have only 1 hour time. That's why I will give on some basic introduction about on metal additive manufacturing. So in upcoming things we will discuss about on slicer and as well as in the post processing of metal additive manufacturing parts. This thing we will discuss in the upcoming webinar. Maybe next month we will discuss about on this. Okay. So anybody doubt in this? Maybe you can ask. Okay. We will end up the session. We will meet again on same like this kind of webinar on the next month. And also you can continuously you can check our website. We will if any webinars or if you are conducting any seminar or if you want to attend any courses, you can check our website. Okay. Thank you.